Okay, so x squared is a function. Nancy?
The x is the change of x.
This is your change of x. Kevin?
1 and 3 already. That thinking, yeah.
This is your integral. Okay, so the symbol means, symbol is telling you that we are dealing with the integral. Ruth? Change of x is very small, so this is essentially 0. Squiggly, approximately. Yeah. That is not equal to, it's approximately. So all that is very good, but what is that actually, what's it actually telling us we're doing? Correct?
You're going to grab the function x squared.
Good.
Between the intervals of 1 and 2.
And that's a great start. So I'm going to actually move this guy down because.
Oh, he can do that. Oh, he can do that. Can you put in the graph too?
Oh yeah, you want to find the exact area on the curve. You're going to find the area under the curve.
So you graph the function, which was already identified as x squared, and you look between 1 and 3, because that's your interval. And that's pretty good. And what do we do? What are we looking at, or what are we trying to do with that graph between those points?
Find the area under the curve.
Good. We're trying to find the area under the curve. And that's a big thing. So this integral, that integral symbol looks like a big S. What is that really saying we're doing? What is a big S?
Sum.
Sum. We're summing up what?
That function.
All the rectangles.
I don't care.
We're adding up all those rectangles. How many rectangles?
Infinite.
Infinite. All right? We're trying to make infinite number of rectangles. That's why this symbol is special. So this is going to be the exact area. This is representing the exact area rather than our estimations that we've been doing where we split it up into 8 or 16. We're going to have infinite number.
The number is
Okay.
1.6.
Oh.
So then we draw a graph. What function do you graph? Ron said it already.
Q squared.
Q squared, sure. Right. And we're looking from 1 to 3. And we're trying to find that area. So a visual representation of what we're doing. Okay. On the calculator, we talked about how to do this, how to actually find the area using the calculator.
8.67. Confirm the area.
It is now.
All right, go home. You know, Sarah, that was recorded for everybody to hear from now on forever.
Okay.
YouTube, you'll be a YouTube bathroom sensation.
And 21.
What do you type into the calculator?
What's that guy's name?
Marcus? 8.67. Henry? Henry? The guy number 4. Why did he start?
Nancy, where do I go?
Math,
Next.
To the math,
Next line.
9,
number 9,
and then you put x
You get
squared,
8.6.
x squared, because that's your what?
your function,
Yeah, that's where.
remember when it doesn't work,
Comma.
x, right,
Comma x,
comma,
comma,
1,
1.
3, close it, enter,
And what does the 1 and 3 stand for?
Interval.
Interval. What does that x stand for?
change of x.
Okay. 8.6. That is your exact area.
Does it stay this easy?
No. Does it ever stay this easy?
That's the thing, like, it's not...
Watch, he's gonna have number 3 that's gonna do something great.
Whoa, whoa.
Stop recording, but we couldn't hear you guys.
Everybody good?
C.
Yeah.
Questions? That's the idea.
And what's the next
Will
part?
be more complex. It's going to get a little bit more complex because you're going to have to do the calculation without a calculator.
What?
Why?
Why would we do that?
Why would we do that? On the syllabus, it does not say that. Where's my book bag?
I'm actually glad we're recording this because then everybody can tell how much complaining you do. Yeah.
Why do you want to?
Where? Where's that? Where? It says
Can
it's
we
right
start over?
here.
You can't see your faces.
I can't hear you. Let's move on video.
No, I need it.
Yeah. No,
The guy you can
There
hear.
will be a video
Mr. Raise it.
of that.
I've signed a date.
Ooh, there's something new.
Just basically.
Oh.
It doesn't matter. What if he?
Whoa, Luke, calm down.
There's Kron. Now he's
There's
now
an
he's
A
actually in the video. Alright.
There's an A in there.
You want less that in my I'm famous guy.
That's a both side.
I'm not really Asian people.
That's so rude.
Here's a fade.
What is that?
That's not me no more.
You gotta write my name.
How is it called?
Are those ears?
It looks exactly like the kids are ponytail.
If the ears are all small.
Write a Q.
Shut up.
Okay, so today, as you can see, we're going to make sure we understand integral notation. Most of you did pretty good with identifying those spots, but making sure we understand that it's finding the area underneath. You need to make sure you understand that aspect of it. And to evaluate basic ones without the use of a calculator. So I know this example on the board, you can all use calculator very quickly and evaluate. Great. I want you to do by hand, right? But the way that you're going to work with these basic ones, there are some cases where you can do it by hand very quickly by just understanding what it means. This is purple because why?
That's really
Yeah, you don't need to copy it down if you don't want, right?
Wow.
We don't have to use calculus for some of these. What we're going to do next week, we're going to start using calculus and actually finding these areas using calculus. But we can find the area of this, we can evaluate this, we can find an answer to this by using simple geometry. And you've done this already. We have done this already. By just making sure we can kind of understand what is going on. Who can tell me, what does this mean? What does this mean?
So, I mean, you got the function x over 2 plus 3, and you look between -2 and 4 to find the area under the curve.
Good. You're finding the area under this curve, this function, between -2 and 4,
With infinite rectangles.
with infinite rectangles. You don't have to use infinite rectangles, and that's where geometry is coming into play.
Geometry is all you need.
What kind of function is this?
Rational. I don't care.
Linear.
It's a linear function.
I was linear.
Oh, yeah, it was.
How is this a linear function? There's a slope. All right, what is the slope? 1/2 x plus 3. Is that easier to see like that?
Grammar. Next.
Yeah, kinda.
So to do this, to do these problems today, we have to kind of graph them. We're going back to graph them. 1/2 x plus 3.
Go up 3.
Go for 3. That's your y-intercept.
1/2.
1/2 is your
Slope.
slope. So you go up 1, over 2,
Ooh, that's good.
and you got your line.
1 down.
Okay?
Ooh, that's
And
good.
where are you looking from?
By -2 and 4.
Wherever -2 is, wherever 4 is.
Whatever it is.
And what are you doing?
Finding the area under the
Finding the
line.
area. Can you find that area without using rectangles?
Yeah.
Infinite number of rectangles.
Yeah.
What can you do with
It's
this?
a line, so it's not really a curve, so you just find the shape.
Okay, you can make a trapezoid, you can
Ooh, trapezoid.
make a rectangle and a
Right, it's triangle.
triangle. Okay,
Mm-hmm.
so find the area.
No.
Go.
Mm,
Ruth, I'm going to record this, make sure parents hear you disagree with me. See what they say about that.
I will lie.
It's recorded right now.
It was right. Put on water, put it to it. Oh no.
All right. So some of you are struggling with this because you are trying to use my messy graph. That is just a really quick sketch. You have to be better with your own graph. All that really matters is for you, Karan said, can you make a table? A table is really all you will need. You need to find what this value is, what this y value is. Some of you are looking at my graph. It's not 2, all right?
What?
Plug in, okay, so plug in -2. -2, -1 plus 3. Okay, it is 2, my bad.
We got that on the recording.
That's true.
He's gonna go.
What about this one up here?
5.
You plug in 4, 4 over 2, 2 plus 3, 5. So then, for this triangle, what's that height?
3.
3, because you're going from 2 to 5, so that's 3. What's your base? 6. So 6 times 3, divide by 2, 9. You got 6. You got 6 times 2, which is 12. 12 plus 9,
Good one.
I told you I was gonna.
21.
I told you.
What did I do wrong? I did my math.
So you plug it in. Back to the.
I did my last. I did my addition wrong. That's embarrassing.
My eyes burn, man. Use it.
Why did you plug in before?
You need to know what the y value is, right here. You need to know how high this guy's going.
My addition wrong.
And you need to know how high it's going over here. If you graphed it very nicely on your graph paper, you would have found those 2 points anyway, just by counting. Right? Kevin? Yes. What do you do with what? 21. Ruth's question is a good question. How do you finish this problem up? This whole expression, this whole thing, equals 21. You just put equals 21.
Would it be like multiple choice?
What? This one has been up.
Yeah, it should be like.
Why don't we just use the equation?
Why don't you just use fn int?
Yes.
You absolutely can. So Edgar asked me earlier, am I correct in my answer? I said you can check. Just use fn int. You can plug this in and you can check. How do you plug it in? We just went through this.
I know how to do it.
Oh, okay, okay, stop. I get it.
Second, enter. And the only thing that we're changing is our function, x divided by 2 plus 3, and negative 2, and we're going to 4. Oh, look at that, 21.
So we don't, so you want to put the extra parentheses around the x divided by 2? What's x divided by 2 plus 3b then?
No, because x divided by 2 will go first anyways. But
If you did put an extra parentheses, you'd still get the same
Oh,
answer. No, so more parentheses won't help as long as you are closing them off properly.
yeah,
Excuse me.
Is everybody okay with this? Questions?
no problem.
Nobody with us?
No problem.
I can talk.
All right. I want you to evaluate the following areas
Using calculator.
by hand first. Once you've done it by hand,
Oh,
once you evaluate it by hand,
I don't get it by hand.
then you can check your work
Yeah,
by using the calculator.
Like, when she did, it really hurt.
Oh, it's 25. 25.
I taught my people, it's not just how to say where.
Is it guys?
Okay, we're back on.
How do you say it?
Is everybody okay with number 1?
Yes.
What does it look like?
Yes.
Every line is straight,
Yes. Horizontal.
a horizontal line. So horizontal line at 5,
At 5.
and you're going from where to where?
From
From 3 to 7.
Yes.
And what kind of shape is that?
rectangle.
So this base is times, so 20. Everybody good there?
Yeah.
Okay. Number 2, is everybody okay with number 2?
Yes.
What kind of
Horizontal.
So holy word.
horizontal line? At negative 20.
I'm doing number 2.
And you're going from 1 to 4.
You got me.
So this distance is 3, and height is
20.
20. Okay, so it's 60. When you did this, anybody check on the calculator?
Yeah, I did.
What did the calculator say?
Nothing because I don't have.
Calculator said negative 60.
Yeah, it really did.
Calculator's wrong. Area can't be negative.
And the areas can't be negative.
What are we in space?
Yeah.
So is it?
Is there a negative outside of parentheses?
So there is a reason why a calculator says negative. This is actually, it is equal to negative 60. The area, if I ask you what's the area, 60 is appropriate, right? We will talk about negative areas and the importance of them.
An imaginary
So it is
number.
negative.
So negative 60, I would accept.
What would you write? That's not right.
We'll talk about when you have to actually call it negative 60 versus when it will just be regular 60. I ask for on the quiz next week. If I say, what is the area in this section? Area is 60. Area, like many of your classmates have been saying, is positive.
When we get it wrong, like you get a 20 point off.
If you said what?
Negative.
Why are you continuing to look at yourself?
I'll put out the black.
Put the brush away. Thank you. And that whole discussion of that whole discussion of positive versus negative areas, some of you checked on the calculator and got one answer, and you said, well, that doesn't make sense with what I did by hand. So this function is what type of function? Linear function with a what kind of slope? Negative slope. So we're up top, and we're coming down, and we're going from -1 to +3.
Oh, no, you don't.
And this is what it looks like. Where we have, or what areas do we have to look at? Both this one and this one. It's important to know where this crosses. It crosses at 2. Don't just guess. If you draw accurately, you'll see that. If you plug in a table, I saw some people plug in a table, that's good. So then the area of this, we have 3, and this one is 6, because plugging in -1, you get 6. So 3 times 6, 18, area is 9. This guy, the distance here is 1, and this is -2. 1 times 2, 2 divided by 2, 1. So the area, what's the area? Add them together. Area is 10. The integral up here, if you did this on the calculator, it would tell you what? 8. Because they consider this, what kind of number? This, what kind of number? Negative. So 9 and -1, 8. Once again, there is a reason to understand both. We need to know how to do this by hand and understand that sometimes where you have to add them because areas don't make sense. Negative areas don't make sense. But sometimes there's going to be applications where negatives do make sense. If you're in physics, we talk about that all the time. Negative talks about going backwards direction, all right? Which kind of, all right? Any questions before we close up?
Is there, we take tomorrow or next Friday?
Tomorrow.
Sorry, I'm trying to hear Rick's question and I cannot. So the area of the, these guys are talking about the areas between the x-axis. That's a good question. We're always focusing on between the x-axis and our function. So here's the x-axis. Here's our function. So where is that between? This is between. Even though it's above now instead of below. It's the same question here. Edgar first had said when he was doing this problem, the area is infinite because you go below forever. There's no stopping point. If you're doing the area under a curve, you're absolutely right. But it's really the area between the curve and the x-axis. Okay? Good question.
Okay.
Everybody else good?
Yeah. Let's do some very